Hey gang, so we are on to chapter 2. So chapter 2 is going to be a pretty basic chapter that most of you will really enjoy. We're going to go through all of this right here in this video. We're going to do slope, point slope, slope-intercept, standard form, horizontal lines, vertical lines, parallel, perpendicular, all this stuff. Chapter 2 is all about functions, domain and range, writing equations, all that kind of thing. Now I want to start off with this first one, slope and gradient. You already know that if we're going to find the slope, we typically call it m, and the formula would be y2 minus y1 over x2 minus x1. We're going to call the slope. IB wants to call it gradient. If you've been in the mountains, you know that it talks about the gradient of a road or the grade of a road. That just means the slope, right? All right. So the other thing we're going to have is slope, intercept, form of a line. But of course, IB isn't going to say the word slope. They're going to say the word gradient. So you might see the word gradient intercept form. Now these mean the same thing. Slope intercept, remember it? Y equals the ever popular mx plus b. That was slope intercept form of an equation. All right, another one that we had, so we've now done this one. Let's do point slope. Well, if you remember, point slope form, well, we need to change it to point gradient or gradient point, whichever way they happen to say it. I'm going to say point gradient form. Well, that's going to be y minus y1 equals the slope times x minus x1. My Algebra 1 students just got through doing a unit where we taught this. We just literally finished it. All right, so point slope form. Now the other thing we had was something called standard form. That's what we call it. IB is going to call it the general form. Still the same thing. One's called standard, one's called general. Now, this is the only form that is a little bit different in America than what we do internationally. In America, we say AX plus BY equals C. And we say that A, B, and C are elements of the real numbers or integers. And we said that A, if you remember, it can't be negative and it can't, none of these can be fractions. You have to get rid of fractions. IB wants to change this just a little bit. We're going to do AX plus BY. But we're going to say plus C, and general form means that the equation equals 0. I actually really like general form because I think it makes a lot of sense to say that. This would help me if I was going to solve a polynomial, if I was going to try and factor it. I would just say put it in general form, and then that automatically means that it equals 0. All right, these are all of our basic forms that we are going to be looking at. Again, all of these are going to be in your formula booklet in chapter 2. Now, the other thing we're going to have, and you may remember these, and you may not, is horizontal and vertical lines. I'm going to put the word lines under there. All right, so if I have a horizontal line, horizontal goes from the left to the right. Vertical lines are just that. They are vertical. They go up and down. Now, if you had me, you learned something called, if you have a horizontal line, the word that I want you to think about is the word hoy. If you have a vertical line, I want you to think about the word vux. Now notice this has an equal on the end, and so does this. That's because a horizontal line is y equals. I'm going to say y equals k, meaning k is just some number. That's all it is. And for Vux, I'm going to say x equals h. And again, h and k, they're just some number, just some constant that they equal. Let's see. Horizontal, vertical, all our standard forms. Let me highlight these. Let's talk about the next one. Horizontal and vertical. Let's talk about parallel and perpendicular. All right, parallel lines. If you remember, parallel lines, they look like this. Parallel lines never ever touch, right? Do you remember what's the same on parallel lines? Well, parallel lines have the same slope. Okay, so let's say that this is line 1 and this is line 2. If the lines are parallel, I would say line 1 and then you put 2 slash marks to show parallel to line 2. If the lines are parallel, that implies that the slope of 1 equals the slope of 2. So for parallel lines, the big takeaway on that is that parallel lines have the same slope. Okay, let's look at perpendicular. Okay, perpendicular lines. And you may remember it's the upside down T, and perpendicular lines make the 90-degree angle. So if you have perpendicular lines where this is L1 and this is L2, they make a 90-degree angle right here. So perpendicular lines, what's the rule? These have the same slope. What am I going to call these slopes? Perpendicular lines have a negative reciprocal slope. Okay, I like to say, because of course I like TikTok, I want to say that you are going to take the slope, you are going to flip it and switch it. I call it flipping the switch. I just flipped the switch. All right, so if L1 is perpendicular to L2, if these two lines are perpendicular, here's what that implies. That if I were to take the slopes and multiply them together, I should get -1. I'm going to let you think about that for just a second. So, for instance, well, you know what, I'll do an example with this to make it a little easier. Oh, I didn't leave myself much room on that. Hold on, let's make sure that's focused. Looks a little blurry. If the slope of this one, let's put it up here, let me put it in blue. If the slope of line 1 is 1/2, then the slope of line 2, if they're going to be perpendicular, I would flip it and make it 2/1 and switch it and make it negative. So it would be -2 would be the perpendicular slope. Let me box that in. This is just an example. Okay. If those are going to be perpendicular, I flip it and switch it. All right, let's actually take a whole example through one of these. I think I can make this work. So here's what I'm going to do. I'm going to come down here. I'm going to do a point right here. I'm going to call that 0, 3. And I'm going to call this point here over 4 up 0. I'm going to draw that line. All right, and so what I'm going to do is take this, I'm going to write this all the way through to general form. So I'm going to start off and I'm going to figure out what is the slope. Let's call this example. All right, so the slope is going to be 0 minus 3 over 4 minus 0. So that's going to be negative 3 over 4. So there's my slope. Now to write the equation of a line in slope-intercept form, y equals mx plus b. M is negative 3 over 4. X, and then I need to look and see what's the y-intercept. It's right here, it's 3, so that would be 3. All right, so this is slope-intercept. So let's write that here. Let's write slope-intercept. Gradient-intercept, whichever one they want to call it. It doesn't matter to me. Okay, now let's write it as y minus y1 equals the slope times x minus x1. All right, so when you go to do that, you need the slope and you need a point. So I'm going to say that the slope is negative 3 over 4. I'm going to pick one of these points. I'm going to pick this 4, 0 since I used the other one last time. So when you are doing point slope form, you have to have a slope in the point. So that's going to be y minus something equals something times x minus something. X stays with x, y stays with y, and the slope goes in the middle. The x is 4. Actually, I'm going to put that in red. X is 4, y is 0, and the slope goes in the middle. I'm going to hippity-hoppity and fix this out. So y minus 0, that would be y equals. Hippity-hoppity, negative 3 over 4x. Negative times a negative is a positive. 4's will cancel, and I'll just have a 3. Oh, look, it's the same thing. I'm going to box that in again. Now, I should have written this earlier, but I didn't. But we're going to write the words point, slope, form. And I'm going to draw an arrow to this up here because that's point, slope, form. Now, if I want to do general form is ax plus by plus c equals 0. So if I want to go to general form, I'm going to take this, which is y equals negative 3 over 4x plus 3. I want to get rid of the fraction first. In order to do that, if I multiply this whole thing by whatever's on the bottom, which is 4, by every single thing, that will get rid of the fraction. So 4 times y will be 4y. 4 times negative 3x will be negative 3x. 4 times 3 will be 12. And now, I no longer have any fractions. But I need to make sure that my a is first and that it's positive. So I'm going to take this negative 3x, move it to the other side, so it becomes a positive 3x. I still have a positive 4y. I'm going to move this 12 to the other side as well, so it becomes minus 12 equals, I moved everything away, so that means it equals 0. This is general form, or standard form. I'm going to call it general form. All right. I might want to highlight that one instead. All right, and there are my 3 forms that I'm going to be using for today. All right, so let's go through and let's do some examples. All right, so the first one we've got here, determine whether the following points lie on the line. Well, all I have to do is mathematically, I'm going to take this, I'm going to plug those points in. So y equals 5x minus 2. I know that x equals 3 and y equals 13. I'm going to plug those in. I'm going to substitute those in. So I'm going to do it this way. So y is 13 equals 5. And then where x is, I'm going to put 3 and then minus 2. If I get a true statement, then it's part of the answer. So 13 equals 15 minus 2. 13 equals 13. So yes, that is on the line. I'm going to try the next one. Now I'm not going to do as much on this. Same equation. So we'll say 3, which is the y, equals 5 times the x is 5 minus 2. You're going to solve that. Same thing over here. Y is negative 2. equals 5 times, and we're going to put 0 minus 2. You're going to quickly realize that 3 does not equal 25 minus 2. So this is a no. Over here, negative 2 equals 5 times 0 is 0, negative 2, so this is a yes. And this one also was a yes. All right, determine the y-intercept and calculate the x-intercept of the line. A couple of different ways to do it. You could graph it and just look, but you can also do y equals 2x minus 10. Well, remember y equals mx plus b, and remember b is the y-intercept, so the y-intercept would be negative 10. So y-intercept equals negative 10. If I want to know the x-intercept, remember that's where you set the y equal to 0, and you would say 0 equals 2x minus 10. I'm going to add 10 to both sides, so 10 equals 2x. Divide both sides by 2, and you get x equals 5. So that means the x-intercept is 5. Could I have done that on my calculator? Absolutely. Could have just graphed it and seen what it was. A line has a gradient m equals 12. Gradient's just slope, and passes through this point, a, which is 4, 8. Find the equation of the line in this form, slope-intercept. Well, I know that the slope is 12, and it goes through the point 4, 8. Well, that means I need to use point-slope form, and I have to use this information to figure it out. So I'm going to do y minus y stays with y, equals the slope times x minus x1, which is 4. I need to simplify this to get it into this form. So y minus 8 equals 12x, hippity-hoppity, 12 times negative 4 is negative 48. Add 8 to both sides, so y equals 12x, negative 48 plus this 8 would be negative 40. Okay, a straight line has a y-intercept of y equals negative 4 and a slope of 25. Find the equation of the line. Well, it has a slope of 25 and a y-intercept at negative 4, right? So that means 0, negative 4. Now, let's say you didn't realize that's what that was. If you were to think about this, it has a y-intercept at y equals negative 4. 1, 2, 3, 4. It has a slope of 25. That means you go up 25 and over 1. So that line looks something like this. Well, you know the slope is 25. Oh, that's the y-intercept. That's the b. So y equals 25x minus 4. A line passes through this point and this point. Find the equation in slope-intercept form. Well, in order to write the equation of the line, I need the slope and I need a point. I'm going to pick this point right here because there's no negatives in that, so I'm going to do 113. But I don't know the slope, so I'm going to have to come over here and say the slope equals 13 minus a minus 5 over 1 minus a minus 2. So that's going to be 28 over 3. I was looking to see, did I write that down wrong? No, I did that. Oh, hello. I'm not adding today. How about 18? How about 18 over 3, which is 6. So that means the slope is 6. I've got my point and I've got my slope. I'm going to write the equation of the line. Y minus something equals something times x minus something. X stays with x, y stays with y, and the slope goes in the middle. I'm going to simplify this hippity-hoppity. Y minus 1 equals 6x minus, did y'all catch what I did on that? I bet you did. X stays with x and y stays with y, and the slope goes in the middle. X stays with x and y stays with y. All right, let's try that again. 6x minus 6. Add 13 to both sides, and y equals 6x plus 7. Sorry about that. All right, moving on. A straight line, okay, has a slope of -3, passes through the point, -1, 2. Find the equation of the line in gradient point form, point slope form. So y minus something equals something times x minus something. X stays with x, which is -1. Y stays with y, which is 2. And the slope goes in the middle. Now this, I'm going to simplify it one spot. -3 times, what am I going to do right here? Two negatives bump together and make a gigantic positive. So that's x plus 1. This is gradient point form. If I wanted to simplify that to slope intercept, I would need to do hippity hoppity and simplify it. But it asks for point slope form. So I'm going to leave it there. Last one, a straight line passes through these 2 points. Find the equation in general form. Well, if I'm going to write the equation of the line, I need the slope and I need a point. For these 2 points, I'm going to pick the easier point, which is 1, 2. Don't know the slope. Let's find the slope. So the slope equals 1 minus 2 over -3 minus 1. That's -1 over -4, which is 1 over 4. So my slope is 1 over 4. I'm going to use this information to write the equation of a line. Y minus something equals something times x minus something. Let's plug it in. X is 1, y is 2, and the slope is 1 over 4. To get to general form, I've got to simplify it and go all the way to slope intercept first. So y minus 2 equals hippity hoppity, 1/4 x minus 1/4. Let's add 2 to both sides. So y equals 1/4 x. And we're going to do, hopefully you can already see those answers. Let me do this. I'm going to do alpha y equals, and I'm going to do -1 over 4. I'm going to add 2 to that. And you get plus 7 over 4. Now, I need to get to general form. So, if I want to get rid of those fractions, both of them are 4. So I'm just going to multiply 4 times every single thing in here. 4 times y is 4y. 4 times 1/4 will be 1x. And 4 times 7 over 4 will just be 7. Well, I need to get everything on the same side. Since x is already positive, I'm going to move 4y to the other side. So I'm going to move this over here. So it's going to become -4y. So I'm going to have a positive 1x. Move this over here. That'll be -4y. 7 is staying put. I could put the 0 on this side, but because I like to put it on the right, I'm going to do that right there. And there's my equation. Standard form, general form, whichever way you want to call it. All right, and I think that is it. Oh, no, we're still going. We're still going. Where are we at? We're at 23 minutes. Here we go. Write in general form the equation of a line parallel to this that passes through this point. So in order to write the equation of the line, I need a point and I need the slope. I've got the point, which is 2, -6. I don't have the slope. I need to solve this for y and figure out the slope. So 2x plus y minus 6 equals 0. Let's move the 2 and the 6 to the other side. So y equals, move the 2 over, that'll make it -2x, and move the 6 over, that'll make it a positive 6. Okay, that means my slope is -2 because parallel lines have the same slope. I'm going to write the equation of this line right here. Y minus a -6 equals -2 times x minus 2. And I need to, am I simplifying that? Oh, let me turn my page. Yeah, I need to put it in, right in general form. That means I've got to put it in general form. So y plus 6 equals hippity hoppity, -2x plus 4. Let's subtract 6. Y equals negative 2x. Subtract 6, so that'll be minus 2. Everything to be in general form has to be on the other side. Let me draw a line down here. So let's move the 2 over here and the 2 over here. That'll be a positive 2x plus y still. Negative 2 is moving over, so it will become a positive 2. And now my equation equals 0. This is the general form. Determine the equation of a line perpendicular to y equals 4. Okay, we might have to draw this one a little bit. Some of you will remember, some of you will not. Y equals 4. That's a horizontal line at 4. If you struggle to remember which way to graph this, just remember if you were to make a T-bar and you say, okay, how do I graph this? Y is 4, but what's x? I don't know, but y, you ask y any question you want, and y says, oh, the answer is 4. What's your name? 4. How old are you? 4. How do I graph you? 4. The only thing it knows how to say is 4. That means it's buffering. Ooh, 4, 4, 4. These can be anything you want. X is good. X can be whatever it wants. That means when you graph it, it's a horizontal line right here at y equals 4. It passes through the point negative 1, 7. Okay, so over here is negative 1 up 7. So we're going to say it's right there. Oh, actually, that would be 4 when it'd be up here. Negative 1, 7 would be right there. I want to know the equation of the line perpendicular to this one. Perpendicular means it makes a 90-degree angle, right? So that means this is 90 degrees. Well, if I have a horizontal line, the only way to be perpendicular is to have a vertical line. That means this line right here goes through negative 1, 7. That is a vertical line. Vertical lines have the word vux that go with them. Oh yeah, because it's x equal. What's the x order of this ordered pair? It's negative 1. That means the equation of that line that is perpendicular is x equals negative 1. All right, find the value of k if the line 2x plus 4y minus 1 equals 0 and kx minus 3y plus 2 equals 0 are parallel. Well, if they're parallel, that means they have the same slope. I'm going to take the equation that I know, which is 2x plus 4y minus 1 equals 0, and I'm going to find the slope of this line. So I'm going to subtract 2x from both sides. So that means I'm going to have 4y minus 1 equals negative 2x. I'm going to add 1 to both sides, so 4y equals negative 2x plus 1. I'm going to divide everything by 4. So y equals negative 2 over 4x plus 1 over 4. I'm going to simplify this, and I'm going to get that the slope of this line right here is negative 1/2. That means if this line and this line are parallel, the slope is 1/2. Well, what would the slope of this line be? Well, we're going to have to do some math. So here we go. So let's take k, let me do this in a different color. Let's take kx minus 3y plus 2 equals 0. And let's solve it just like we did right here. So let's see, let me do this. Let me subtract kx from both sides. So negative 3y plus 2 equals negative kx. I'm going to subtract 2 from both sides. So negative 3y equals negative kx minus 2. And I'm going to divide everything by negative 3. So y equals, when I divide negative k by negative 3, are you with me that I'm going to say k over 3x? Because two negatives are going to make it positive. And I'm dividing this, so this will be a positive 2 over 3. Because negative 2 divided by negative 3 will make this a positive. So here's my two equations. What I know about these equations is they are parallel. That means their slopes are the same. So here's what I can say. I don't have much room left because I should have left more room, but I didn't. I can say that negative 1/2 must equal k over 3. If these lines are going to be parallel, then these slopes right here have to be the same. That one and that one have to be the same. Cross multiply. So this would be -3 equals 2k. I would divide both sides by 2, and I'm going to get k equals -3 over 2. If the lines are parallel, the answer to this one is k equals -3 over 2. Now, on the other side, if I want to say that they're parallel, then I know that the slopes have to be flipped and switched. Well, I know the slope is -1/2, right? So if the slope is -1/2, perpendicular slope, it would be a +2. So are you good taking the same equation here? Here's the slope of this one. These two lines now have to be perpendicular. So I'll take k over 3 has to equal this new perpendicular slope, which is 2. I can put it over 1 if I want it. That helps me cross multiply and get k equals 6. So if the lines are perpendicular, k would be 6. If the lines are parallel, k would be -3 over 2. All right, number 11. So triangle ABC has a right angle at vertex A. Has a right angle at vertex A. So here's my right angle. I'm going to call that A. Which A also has coordinates -1, 8. Going to go ahead and label that. Let's see, the sides BC and AC are formed by lines. So let's see, I'm going to say if this is A, I'll call this BC, ABC. So, how I label it really doesn't matter as long as I have this one labeled right. So, the side BC and AC, so BC and AC are formed. So I'm going to say that BC, since BC's first and this equation's first, I'm going to call this line right here BC, which is 4x plus 1. And AC, which is listed second, this one is second, is y equals -3x plus 5. Okay, find the coordinates of vertex B. So they want to know this coordinate right there. Okay, well, here's my thinking. If I knew this line right here, I know it's perpendicular to this line, so I do already know the slope of this line, but I wonder, could I just write the equation of this line and then figure out where these two lines intersect? Because where these two lines right here intersect, that's the ordered pair right there. So let me do this. Here's what I know. I'm going to write an equation for line AB. To write the equation of a line, I need the slope and I need a point. Do I have that? Yes, I do. The point on this line that I know is -1, 8. The slope of this line, well, these two lines are perpendicular. Perpendicular lines have a negative reciprocal slope. If the slope is -3, if I flip it and switch it, it would be 1/3. Let's write the equation of this line, AB. It would be y minus something equals something times x minus something. So y is 8, x is -1, and the slope is 1/3. I'm going to write this equation. Y minus 8 equals hippity-hoppity 1/3 x minus 1. Ooh, nope. Two negatives bumped together make a gigantic positive. 1/3 times 1 would be a positive 1/3. I need to add 8 to both sides. So y equals 1/3 x. 1/3 plus 8. Okay, I've already done that math. If you add, remember you're adding 8 plus 8. It actually comes out to be 25/3. This is the line AB. Okay, well, if I could figure out where this line and this line intersect, where does AB AB intersect BC? Where do they intersect? Well, here's what I know. I know that AB is y equals 1/3 x plus 25 thirds. I know that BC is 4x plus 1. I'm going to use my graphing display calculator. We're going to find that intersection. Here we go. I'm going to say alpha y equals 1/3x plus alpha y equals 25/3. 4x plus 1. I'm going to graph these. I need to figure out where do these two lines intersect. So I'm going to say second, calculate intersection. See how it's on the blue? I'm going to hit enter, and it's going to jump to the red. Enter. Want to guess where these two lines intersect? Yes. And here's what it says. The intersection right there where it's blinking is over 2 up 9. Now that means if I would have gone to the table, hold on, let me get this. If I would have done this on the table, look, 2, 9, 9. That means that's where those two are the same, and that's where the answer is. So where is the ordered pair for B? It is at 2, 9. All right, last one down here. Are the following points collinear? Do they lie on the same straight line? All right, we're going to cheat a little bit on this one. I don't know if you remember this from the last unit, but I'm going to see if you do. You're going to go to Stat, Edit, and we are going to put these ordered pairs in. 0, 4, -10, -3, -4, -12. We're going to go to Second, Stat Plot. We're going to turn the statistics plots on. Okay. Now when I graph it, it's going to graph those points. Now this line right here is the ones that I just did. So I'm going to go to y equals, I'm going to clear those out so that they're not there. Okay, these are the ordered pairs that these are. But I can't see it. So we're going to hit Stat, and we're going to hit, I'm sorry, not Stat. We're going to hit Zoom, and we're going to hit number 9 for Zoom Statistics. Let's zoom to those plots. Oh, here's the points. So if I were to graph them, 0, let me, is that a red? No, it's a blue. 0, -3 would be here. 1, 2, 3, 4. 1, 2, 3, 4 would be there. -10 is here. And -12 would be here. Do those points look linear? No. You can see it on here, but you could also see it in here. Where it's a little more difficult is if the points were more spread out. But I can definitely say, yeah, no, they are not. If I wanted to do this by hand, I would compare the slopes. The slopes would have to be the same. So the slope of AB, which would be -3 minus a -4 over 0 minus 4, would be 1 over -4, or -1/4. And the slope of BC would need to be the same. So the slope of BC would be -4 minus a -12 over 4 minus a -10. And this would be +8 over 14. 2 goes into that 4, and 2 goes into that 7. These are not the same. If I asked you algebraically to show me this, or mathematically, you would have to compare the slopes. If I just ask you, is it straight up? You can just say, oh, GDC, Graphing Display Calculator, and the answer is no. All right, I believe that is it. Yes, it is. That concludes this first section.